Kia ora koutou. Here is question 1e from the integration exam today. This is one where you're given a differential equation and you have to show something about the constant that you end up finding. So there's no numbers at all in this problem. So it feels like an excellence question before we even get going, but it's just a really cool little problem, and it comes out pretty easily if you've set it up right. So let's just read through carefully first. The rate of change of quantity n at any instant is given by the dE. This, in other words, the rate of change is proportional to the current level of the thing, so it might be the population or something like that. And if n has positive values, n1 and n2, at times t1 and 2t1 respectively, prove that k is equal to this. Okay, so let's get going, and we're going to use the only thing that we know how to do in DEs at level 3, which is to separate the variables. So we're starting off with the DE, which is this thing here, and we're just going to write down our 2 points off to the side here. So at time t1, the quantity is n1, and at time 2t1, the quantity is something else, and we don't know anything about anything except for that. Right, so separating the variables gives me this. This should feel very familiar if you're doing excellence questions. So we integrate both sides with respect to n and with respect to t, and on the left-hand side we get the natural log of n, and on the right-hand side we get kt plus c. So there are different ways to go here with where you put the constant and stuff like that. This is just the way that I do it. I'm sure there are other ways that you might like to do. So now I'm going to e to both sides, or exponentiate both sides, and I get this. I get n is equal to e to the power of kt plus c. Now I know that I can lose the absolute value signs because I know that this thing here has got to be greater than 0. That's the simplest explanation. Splitting that up, I get n is equal to e to the kt times e to the power of c, and we can rewrite that constant as a big A, so ae to the kt. Okay, so now it's time. We've got the general form, and we have got two constants in here. There's a and there's k. Now it's time to go back and look at where I'm trying to get to. Well, I'm trying to get through to k equals blah, 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 and you can see that there's no a in there. So you might want to think, how can I eliminate that a? Next thing we're going to do is substitute in the 2 points that we've got. So the first point, n1, t1, or t1, n1, is this, fits this pattern. And then n2 is equal to a, e to the k times 2t1. And I'm going to divide one by the other. So n2 divided by n1 will give me a e to the 2k t1 over a e to the power of kt1. So n2 over n1 is equal to e to the power of 2kt1 minus kt1, because I've got the same base here, so I can just subtract one power from the next. That simplifies to give me, sorry about the background violin playing, guys, but at least someone is doing their violin practice. So there we go, we're nearly there. We need to solve this now for k. I'm going to take logs of both sides, and I get kt1. So we're done, right? K is equal to 1 over t1 times the natural log of n2 over n1. And I was very helpfully told that n1 and n2 were both positive, so there are no dramas at all with the argument of the natural log function. There you go. A nice straightforward question if you are comfortable with solving DEs and not working with a whole lot of numbers. Let me know in the comments which one you'd like done next, and I will do it tomorrow night. Thanks for watching.